Okay, in this third part, I'm going to back up a little bit to explain a couple things. As luck would have it, there's some wind noise in the background. It's extremely windy tonight, but I want to get this this video done before I work on another major project in the house, and I won't be able to do videos for a couple days. So all of my explanations center or are in this camp here. There's basically 3 camps of flint knapping. Okay. And for beginners, this is where it can get very important to know the different camps. Okay. Now this is basic. All right. There's other branches and other divisions, but these are the basic camps. Okay. I do most of my work freehand, which means I hold a workpiece out in the air in my hand. Okay, and on a pad as well, but I'm out in the open. I don't have any extra things to brace it other than my hand. Okay, I don't usually back up to my leg or whatever. My techniques are freehand. Okay, so I'm in the freehand workpiece camp. Okay, and that's important to remember in my videos, because if you're over here where most people are, in the braced workpiece camp, some of my explanations won't work for you, and you're going to wonder why, if you follow my advice, it's not going to work, or it's not working for you. And it's because I'm in this camp over here. Now most people are in this camp here where they brace the workpiece. They have a very rigid hold on it. They've got it backed up to something. They back it up, or they hold it extremely rigid with a backing on their leg or some other backing. That's what I call braced, or they add another rock in here somewhere to add mass to the workpiece. You know what I mean? This is braced. This is what I call braced. It's extra force to hold this workpiece rigid, and it also includes a stiff pad, like some of these conveyor belt rubber pads. This is not it, but just to show you, an extremely stiff pad. An extremely stiff pad is also what I call braced. Okay, because it's extra, something extra other than your hand. Okay, I use a leather pad just to protect my hand. That leather pad doesn't really add much to the bracing of this workpiece. That's why I call it freehand. Okay, so most people are in this camp here, the braced workpiece, with passive pressure, and I explain these in my other videos, and I'm not gonna explain these in this video, but just so you'll know the terms I'm going to use. Most people are in this camp here with passive pressure, slow hammer percussion, and vertical punches. Okay. Most of the videos, most of the books, most of the advice is in this camp here. Okay. There's also a camp of jig assisted workpieces, where you construct some sort of device to help you remove flakes. I'm not going to get into that until much later on in my videos. These are my main 2 camps, but 90% of my flint knapping advice is going to pertain to this here: aggressive pressure, fast hammer percussion, and a horizontal punch. Okay. So for those of you guys that are in this camp over here, you may have difficulty understanding where I'm coming from, but just keep that in mind. Okay, so first off, I reviewed the last video, and I wrote some notes on some areas that I kind of left hanging in that previous video, so I'm going to go over some of those areas and try to tie up those loose ends that I left hanging. One is that I noticed, in the diagram of the workpiece, it's actually way too thick to be useful, I think. Here we go. We got some focusing issues. All right. Most workpieces that people want to do thin flakes on are looking more like this than this. Okay, and where do you find a platform on something like this? On thin pieces, your platforms are very small. I mean, if you zoom in to this edge, it'll look like this, okay? But in general, you can be working with this kind of a cross section and trying to remove long flakes on this kind of cross section, okay? And your platforms are going to be quite small. You're going to try to do something like this on the edge. Either look for it or create this type of situation where you can actually put the tool somewhere on the edge and not on, not on the sharp part, because you're not going to get anywhere. You have to dull it in some way. But the platform will be very small. Okay? I just want to clarify that, because this might confuse people, or it might appear to be non-useful, which it can be if you're working thin workpieces and you want to drive long flakes on thin workpieces, which is the most difficult thing to do in flint knapping, but that's what most people focus on. When they have difficulties, they want to know this. They really don't want to know this part where, yeah, I can remove flakes off a thick piece. That's not what I'm looking for. I'm looking for this here. How do I thin down a thin piece? But my techniques and my explanations work on this, okay? They do work on this type of workpiece. Okay. Next on my notes is how do you remove a flake from an edge that is obtuse, okay, greater than 90. How do you do that? Because most explanations are not pertaining to greater than 90. Well, the easiest way to remove a flake is to create a concave situation. And let's see, I gotta make sure this is obtuse. Okay, make sure you can create a concave area. Let's see, how do I express this? Let's see. This is, it's easy on a large, when you have a very thick, blocky workpiece, you're not going to have obtuse angles like this on the edge of a very thin workpiece, so you don't have to worry too much about it. You can create a concave area and then use the tool in here to create an initiation in this concave area. Okay, you can put the tool here, strike inward, and create that. But I think this is greater than 90 here. It works, when you're working on a thick, very thick core. That's when this comes into play. And what you want to do is take out a chunk, try to strike a flake off in that direction first and create a concave area, and then strike off a flake or apply force in this direction to initiate a flake. Okay, concave. The other way is something you can do on any surface is if you have a step. Okay, you can get your tool, if that step is tall enough, You can get your tool in there and initiate a flake by applying force to this little step that's sticking out. Okay. Now this can be, if you zoom in on this, technically it'll look similar to this, and that'll be like a 90 in here. Okay. See if I can get this. All right. This will be close to 90, but this whole edge here is not. Okay, you'll have to create a 90 in there. That's one way. The other way is through some sort of abrasion to roughen this area so that when you apply force, you have more friction. If this area is rough, if you roughen it a lot, this tool will grip sufficiently to overcome the thickness, and you will be able to initiate a flake. Okay, so surface roughing, I guess you can call it, or creation of a of an acute area. Okay. There are two ways you can go about creating flakes on areas that are on edges or areas that are greater than 90. Okay, just wanted to get that out of the way in case you were thinking about that and had some questions about that. Okay, hopefully I did that okay and not confuse anybody. All right, the other thing is, since flintknapping is so subtle, it's very important that I be exactly correct in my illustrations, or it can throw you off. So I was going over, how to place the tool on the edge of the workpiece. Okay. And I mentioned that you can strike above the platform or above the edge or margin, or right on the edge or margin. Okay. Often you'll see the word margin in archaeological texts to mean edge. All right. Now, this type of initiation is in two forms. Okay. You have a Hertzian, and I hope I'm spelling that right, and non-Hertzian. And this one here is primarily non-Hertzian over here. And what that means is, you've heard the Hertzian cone idea, where the force is applied to like a pane of glass. It's a very common explanation for a Hertzian cone. Okay, it pops out this little cone, and you have these edges that look like that. Okay, that's Hertzian. Okay, and what happens is you can create a Hertzian initiation here, like this, with this kind of force above the platform, or above the edge, I should say. Okay, this whole thing is a platform. Wherever you strike is a platform. Okay, even if it doesn't look like a platform, if you end up striking it, technically it is called a platform. Anything that is struck. Now, some platforms are good and some are not, but a platform, the way I define it, at least for this video, is anything that you actually strike, even if it's not a proper platform. Any edge that is strikeable is a platform. Okay, so you can create a Hertzian type of situation by applying force on this platform right at the point of impact, just like this one here. Okay, but you can also create a non-Hertzian initiation, which doesn't start out as I'm getting focus problems here. It doesn't start in this direction. Okay, it actually starts, let's see, the flake initiation starts in this direction and then moves let's see. It starts off like this and then moves, creates a bulb, and then it finishes. Okay, it starts in almost the opposite direction as a Hertzian initiation. Okay, so that's why I call this a non-Hertzian, and it produces a lip or a spur. Okay, so just to be clear on that. Okay, this can also be a Hertzian type. I mean a non-Hertzian over here also. So you're going to create both types. Either type, you know, it could, if the softer the tool that's used, the more inclined it's going to be a non-Hertzian initiation. Okay, the harder the tool, the more like it's going to be like this. Okay, now it's extremely important to know that when you're getting good at flint knapping. But as a beginner, just be aware of that. There's some differences there, and you know, you won't be doing this type of, or be paying attention to this subtlety here, okay, until you get more advanced. But just be aware that there's two different types, and I wasn't that clear on this. And the actual placement of the tool, or the actual impact area, okay, it's not exactly on that, it's a little bit off. Okay, but the non-Hertzian initiation is further away than the Hertzian initiation. Okay, there's really not that much space there, but you can see the difference. Okay, hopefully you can see the difference and be aware of it. Okay, the tool, when you're flint knapping, these distances sometimes are so small you won't notice. I mean, it's hard to tell, but that's what's going on. Okay. All right. And another thing I was talking about is the flexibility, you know, of the tool. Now, a horizontal punch cannot be too flexible. And I would argue that both a punch or a flaker, you know, pressure flaker, cannot be too flexible. I like it to be snappy. Okay, that's why I don't use Delrin. I don't use Delrin. I use what they call UHMW-PE plastic rod. Okay, this is different than Delrin. Okay, these are two different types of material. This is not as flexible. This is a lot more snappy and is much more like antler. Okay, so I wanted to clarify that because it does make a difference. I've had some guys make their flakers out of a very flexible material, and then ask me, you know, why is my flaker not working? I'm making the, you know, to the exact dimensions that you made yours, and mine just doesn't work at all. It could be that you're using a material that's too flexible. Okay, so if you want to make tools exactly like mine and work exactly like mine, they've got to be the exact same material. Okay, and for beginners, that's critical. Everything has to be exact for beginners. When you get more experience, it really doesn't matter too much. But when you're beginning, these little subtleties are critical. Okay, so I just wanted to clarify that one too. All right. The last thing on here, let's see. Okay. I got some notes here on vertical punches. There's difference between vertical punches and horizontal punches, okay? And I think I went over that a little bit here. Most people use the vertical punch. Now, some other videos that'll be helpful to you probably. I think I have one on spring theory. I'm not sure where, you know, how far back that one goes, but I think I did a video on spring theory. I think that's what I called it. So that would help. I also have my elbow horizontal punch. That's one of my latest demonstrations of the horizontal punch that goes into details on exactly how I do my technique. Okay, so just to give you a conclusion on this three-part series, the most important thing I think for you to remember or to learn is that the system is dynamic. Okay, with my technique, there's a lot of play before the initiation of the flake. So you may start with an angle of the workpiece and tool like this, and then apply force or pressure for some distance before you actually get a flake to release. Okay? And let's see, there's one other question. I think I'll just get into other questions in the next video. It's already 22 minutes. So this is mainly just a clarification and a summary. The most important things to realize is that this system is dynamic. If I give you an angle of, let's say, 170 degrees is the initiation of the flake, or 160 degrees or whatever, some people will say, okay, I'm going to find a way to measure exactly 160 degrees and then hit it and then end up with a real short flake, and you'll say, what the heck happened? Well, you have to start higher than that because there is play in the system. Okay, I don't know, maybe you'll have to start at about 140 or something. I really don't have a way to measure effectively. I'm going to try though, but it's very difficult to measure the initial angles and the angles of the flake release. These types of measurements are very difficult. Even the definition of the platform angle is very difficult for lithic analysis and for archaeologists and experimental archaeologists to define. Okay, so when someone asks me, a seemingly simple question on what is the proper angle, you've got to understand that it's extremely difficult to measure. Okay, because where do you might measure the center line. That's what I prefer. I prefer to go by center line here and center line here. But if it's not a clear system, like what happens in this case, center lines are way off, okay, compared to these center lines. Vertical punch forces and center lines are completely different than these horizontal punch, and sometimes yielding the same result. Okay, so just keep in mind that I'm in this camp over here. Okay, I'm in this camp here, and I'm talking mainly about pressure flakers and horizontal punches in this 3-part series. Okay, and I am biased toward the horizontal punch. Okay, so again, the next video is probably going to be how to avoid step fracturing. Okay, and I'm going to need some time to get that one prepared, because this is one of the other very, very valuable and very, very difficult questions to answer. Okay, so hopefully that helps, and that's it.